We want to look for the angle that lies between two lines. Now, if you have two distinct lines in a plane, if they're distinct, that means that they're either parallel or they're going to intersect. And when those two lines intersect, we get two pair of opposite angles. For instance, if I have line L that intersects with line K, we have two pair of opposite angles. We have this pair and we have this pair. And hopefully you remember from geometry that those are vertical angles, and vertical angles are congruent angles. Now we consider that the acute angle is the angle between the lines. Now, in order to calculate the angle between the lines, we can use the angles of inclination. And I'm going to make this a little bit bigger. Notice here I have two angles that intersect, and the acute angle between those angles we're calling theta. We have theta 1, which is an angle of inclination, which is the positive angle between the x-axis and the line. And we have theta 2. In this case, theta 1 is less than theta 2. The measure of theta 1 is less than the measure of theta 2. And if I were to subtract theta 1 from theta 2, we know that it would still be less than 90 degrees, or pi over 2, because both of these are acute angles. Now, recalling from geometry, I have a triangle here if I look at the x-axis. And let me change the color. If we think about this triangle, notice that I have theta 1 if I didn't make my triangle big enough. This is the triangle we're looking at, sorry. So I have theta 1. If this angle is theta 2, then the angle inside the triangle is 180 minus theta 2. And if I wanted to find the measure of this angle, which is congruent to my theta, we can use the idea that the angles of a triangle add up to 180, so we would have 180 minus the sum of the other two angles, 180 minus theta 2 plus theta 1. And if we simplify, we're going to get 180 minus 180. A negative times a negative theta 2 gives us a positive theta 2 minus theta 1, which is this angle, which is also equal to theta. So we can say that the angle of inclination between two lines is equal to theta 2 minus theta 1. Now, if theta equals theta 2 minus theta 1, we can find a formula for us to find the tangent of the difference of two angles. Because remember, the tangent of an angle and the slope are the same thing. And if we have the value for the tangent, we can use the arctan in order to find the angle. But hopefully you remember back from a short while ago, we said that the tangent of theta, in this case the tangent of theta, is going to be equal to the tangent of theta 2 minus theta 1. And that's a formula that we learned when we were looking at the sum and difference of angles, which is the tangent of theta minus of theta 2, minus the tangent of theta 1 over 1 plus the tangent of theta 2 times the tangent of theta 1. That's a formula that we learned a short while back in a different section. If that's true, we can take that and make it a little bit simpler to work with. If we have two non-perpendicular lines, two non-perpendicular lines that have slope m1 and slope m2, then we can find the angle between the lines by saying that the tangent of theta is equal to the absolute value of m2 minus m1 over 1 plus m2 times m1. Now notice we have to use absolute value because we're always going to have a positive acute angle. We don't ever want a negative angle. That angle has to be acute. And if you're not given which line is line 1 or line 2, because it's absolute value, you're going to get the same answer no matter which one you choose is line 1 or line 2. So let's look at an example. If line 1 is equal to 2x plus y equals 4, and line 2 is x minus y equals 2. Now we know we can solve for y to find the slope, or you might remember that slope is equal to negative a over b. So for line 1, the slope is equal to negative 2 over 1. For line 2, the slope is equal to negative 1 over negative 1, which gives us a slope of 1. And now we can simply plug that information into our formula. So we could say that the tangent of theta is equal to the absolute value of slope 2 minus slope 1 over 1 plus slope 2 times slope 1. So we get that the tangent of theta is equal to the absolute value of 3 over 1 minus 2. But since it's absolute value, we want the angle whose tangent is 3. So if you use your calculator, you can do the arctan of 3 and find that theta equals 1.249 if you're in radian measure, or you can multiply that radian measure times 180 over pi and find that theta equals 71.565 degrees. One thing that you need to remember that when you find the angle between the lines, it's always an acute angle. And as I said before, if you're not given line 1, line 2, if they don't specify line 1 or line 2, because you're taking the absolute value, you will get the same answer. There are times when you will be asked to find the distance between a point and a line, and there's a formula that we can use for that. The distance between point that's designated with x1, y1, and the line ax plus by plus c equals 0 is found using the formula distance equals the absolute value of a, and substitute in x sub 1, whatever your x value is, plus b, substitute in whatever your y value is. And you take absolute value, because the distance is always positive, over the square root of a squared plus b squared. So this is a formula that we'll be using to find the distance between a point and a line. So if I have the point 4, 1, and I want to find the distance between the point 4, 1 and y equals 2x plus 1, the first thing I have to do is convert my equation for the line so that it's in standard form. So this becomes 2x minus y plus 1 equals 0. And to find the distance, we plug in a 4 for x, 2 times 4, minus 1y plus 1 over the square root of 2 squared plus 1 squared. So distance is equal to the absolute value of 8 over the square root of 5, or just 8 over the square root of 5. And this is one of those cases when you may leave the square root in the denominator. Here we have a triangle that's formed by giving, I have vertices of the triangle that are on the coordinate plane. And in this triangle, I want to find the length of the altitude from point B to side AC. So I want the length of this altitude, which if it's an altitude, that means it's going to be perpendicular to side AC. Now notice I have a point and I have a line. If I want the length of the altitude, I can find the length of that point, or the length of that altitude, if I can find an equation that would satisfy the line AC. So hopefully you remember that in order to find an equation, we can use the point-slope formula. Which is y minus y sub 1, one of those y value points, equals the slope times x minus x sub 1, point-slope formula. So the first thing we have to do is find the slope of AC. And the slope of AC is change in y over change in x. So if I start with point C, I'm going to have change in y is 2 minus 0 over change in x is 5 minus negative 3. 5 minus negative 3, which gives me a slope of 2 over 5. I'm sorry, 2 over 8. Which is 1/4. So this is my slope that I'm going to plug in to this formula. So we're going to have y minus y sub 1. Now I have to choose either A or C. Choose one of those points for my equation for the line. And since point A has a 0 in it, that's the one I'm going to choose. So we have y minus 0 equals 1/4 times x minus a negative 3. Just to simplify things, I'll multiply by 4. And then put it back into standard form. So we'll have 0 equals x minus 4y plus 3. Reason I did this was because I want to find the length of the altitude. I have a point. Now I have a line that I can use to find that distance. So remember we said that the distance is equal to the absolute value of, plugging in for x, I'm going to plug in a 0 because this is now the point that we're using. That's point B. So 0 minus 4 times 4 plus 3 over the square root of 1 squared plus 4 squared. So we get the absolute value of negative 16 plus 3, or 13 over the square root of 17. That is the length of the altitude from point B to the opposite side of the triangle, or segment AC. So that's the length that we were looking for. Now we're going to have to use that to find the area of the triangle, because remember, the area of a triangle is 1/2 the length of the base times the height. We know what the height is. We just found the height when we found the altitude. This is the altitude or the height of the triangle. So in order to find the length of the base, I'm going to have to use a distance formula. Distance between 2 points. The formula for the distance between 2 points is x2 minus x1 squared plus y2 minus y1 squared. So the distance here is 5, square root of 5 minus a negative 3 squared plus 5 minus a negative 3 squared plus 2 minus 0 squared, which is equal to the square root of 8 squared plus 2 squared or the square root of 68. And 4 goes into 68 7 times, so we get 2 square roots of 17. That is the length of segment AC. So now I have a height and I have a base. So the formula is area equals 1/2 the base times the height. And this is nice. The 2's cancel. The square root of 17 cancel, and we find that the area is 13 units squared. Okay, these are the formulas that you'll need for your homework. And these are examples that you can look at for your homework, which is on page 730. And you have 37 to 45 odd, 51 to 60 every third, and 62, 65, 66, and 67.